Before we pass our captured design into the PCB for layout, we want to prepare the PCB by defining the board extents. Before we begin component placement, we want to define and modify document options and design rules and define the layer stack we plan to use. So first, let's go ahead and get our board shape defined. This is a small PCB, so let's just make a 30mm by 30mm square for now. We will start by setting the origin and defining our snap grid. There are two origins used in the software, the absolute origin, which is the lower left of the workspace, and the user definable relative origin, which is used to determine the current workspace location. Before setting the origin, keep zooming into the lower left corner of the current board shape until you can easily see the grid. To do this, position the cursor over the lower left corner of the board and press page up until you can see both the coarse and fine grids visible. To set the relative origin, we will go to the Home tab, and then under Grids and Units, we want to go to Origin and Set. We're then going to position the cursor over the lower left corner of the board shape until we see that snap into place, and then left click to set it. The next step is to select a suitable snap grid. The grid is set in the Grids and Units section of the Home tab of the ribbon. During the course of design, it's quite common to change grids. For example, you might use a coarse grid during component placement, a finer grid for routing, which can be done by selecting a new value from the drop-down list or typing in the required value directly, and then press Enter to have your value accepted. For this tutorial, we will be using a metric grid, so we want to go ahead and click on the metric button to set it to the metric grid. And the first grid we will be using is 5mm. So let's go ahead and enter that value into the snap grid field. The default board shape is 4 inches by 4 inches. For the tutorial, the board size is 30mm by 30mm. To zoom back out and show all of the workspace currently being used, we can go to View, and then on the zoom, use Zoom All, or again, the hotkey for this is Control Page Down. The next step is to change the board shape to 30mm by 30mm. The choice now is either to redefine the board shape, essentially draw it again, or edit the existing board shape. Now for a simple square or rectangle, it's more efficient just to edit the existing board shape. To do this, we're going to go to the Home tab, into the Board area, and then under Board Shape, we want to click the pull down, and then we want to go to Edit Board Shape. The board display will change with the shape shown here. Editing handles will appear at each corner and at the center of each edge. Now if we click anywhere other than on an editing handle or on the edge of the shape, this will drop you out of board shape editing mode. If this happens, just go ahead and go back in and click on that command again. The objective is to resize the shape to create a 30mm by 30mm board. The coarse visible grid is 25mm, essentially 5 times the snap grid, and the fine visible grid is 5mm, and this will be used as a guide. So you can now either slide the upper and right edges down and in to create the correct size, or move the 3 corners in, leaving the one side that is at the origin in its current location. To slide the top edge down, we want to position the cursor over the edge, but not over a handle. And we can note the difference in the cursor. This would be the corner, and this would be the edge, only allowing us to go up or down. Clicking on the middle handle here would actually add a new vertex. And we can see the difference in arrows on the top and on the right. To slide the top edge down, position the cursor over the edge again, and then we get the double-headed arrow, and then click and hold, and we want to now drag that edge to the new location so that the Y cursor down below is at 30mm. We then want to do the right-hand side, and again, we're going to drag that over until the X value is at 30mm. Then again, click anywhere in the workspace that's not on a handle to drop out of the board shape editing mode. And again, if you accidentally click out before you're finished, simply go back to board shape and re-enable the mode. Once we have this done, go ahead and do a control page down again. Once we have this done, we'll go ahead and save the board. So control S or click on the save icon. The process of transferring a design from the capture stage to the board layout stage is launched via the update command. Under the Home tab, Project, and then Update PCB document from the schematic ribbon, or from the PCB side, again under the Home tab, Project, Import changes from Project on the PCB side. Now, when you run this command, the design is compiled and a set of engineering change orders is created, which will list all the components used in the design, the footprint required for each, and when the ECOs are executed, the software will attempt to locate each footprint in the currently available libraries or available content vault and place each into the PCB workspace. If the footprint is not available, an error will occur. There will also be a list of all nets, your connected component pins, in the design. When the ECOs are executed, the software will add each net to the PCB and then attempt to add the pins that belong to each net. If a pin cannot be added, an error will occur. And this most often happens when the footprint was not found or the pads on the footprint do not map to the pins on the symbol. So let's go ahead and set the schematic document as the active document within Circuit Studio by clicking on its Document tab. I want to select the Home tab, Project, and then Update PCB document within the project. The project will compile and the engineering change order dialog will open. Go ahead and click on Execute Changes to send the changes to the PCB editor, and when completed, the target PCB will open with the engineering change order dialog open on top of it, and the Done column entries become ticked. Go ahead and close the dialog and complete the transfer process. The components will have been positioned outside the board, ready for placing on the board. There are a few steps before starting the component process, such as configuring the placement grid, the layers, and the design rules. As well as the layers used to fabricate the board, including your signal, power plane, mask, and silkscreen layers, the PCB editor also supports numerous other non-electrical layers, and the layers are grouped in the following way. Your electrical layers, this includes the 32 signal layers and 16 internal power plane layers. Your mechanical layers, there are 32 general purpose mechanical layers used for a variety of design tasks. And then you have your special layers. These include the top and bottom silkscreen layers, the solder and paste mask layers, drill layers, keep out layer, which is used to define the electrical boundaries, the multi-layer, which is used for multi-layer pads and vias, the connection layer, DRC error layer, grid layers, hole layers, and other display type layers. Now, the display attributes of all layers are configured in the View Configurations dialog. To open this dialog, we can either go to the View tab, and under the Switch to 3D menu, we can click on this and go into View Configurations and bring up the View Configuration menu entry, or significantly easier, just click down here on the color box in the lower left of the workspace. So open the View Configurations dialog, and in the Board Layers and Colors tab, confirm that the two signal layers are visible. Note that this dialog is where you control the display of the mask layers, the silkscreen layers, system layers, such as DRC and grids. To have less visual clutter during placement and routing, you can disable the display of the mechanical layers. Go ahead and turn those all off. And we can just turn off all of the mask layers as well. And we do not need the drill guide or the drill drawing layer. If we go to the View Options tab up above, we just want to make sure that the Show Pad Nets option is enabled and that the net name on tracks display is set to single and centered. And with that done, go ahead and press OK or press Enter to close the dialog. So now we're going to go ahead and set the snap grid. The value of the snap grid can be configured directly in the Home tab of the ribbon, or it can be configured in the Cartesian Grid Editor. If we go into the Home tab, Grids and Units, and click on the Properties button, this will open the grid editor. You can also access this grid editor directly using the Control-G shortcut key. We're going to go ahead on the step X field. We're going to go ahead and enter a value of 1 millimeter. And because the X and Y fields are linked, there is no need to define the value for Y. To make the grid visible at lower zoom levels, we want to set the multiplier to a 5 times grid step. And to make it easier to distinguish between the two grids, we want the fine grid display as a different color, and we're going to go ahead and also change that to dots. And then we're going to go ahead and click OK to close the dialog.